answer by taking 1 to 2 minutes after thinking. Don't tell me quickly. You won't get anything. You won't get any fund or refund. Just think about it.
Sir, horizontal movement is arrested by both fixed supporters, sir.
Here I'm not saying anything. I'm not saying anything about axillary rigid. Nothing I'm saying about. If I tell you axillary rigid, then only you guys have to think about that case. At present, just tell me in general what is the kinematic indeterminacy.
So there is a hinge.
There is a.
So D
is there is any hinge at D?
No, I just.
We thought it is hinge.
No, that is not a hinge.
Oh, okay.
I just want you to get your clarity that cable is connected at joint D. That's it. There is no hinge there.
Okay.
Okay. It just tell you that it is connected here. Nothing else. Come on. Think. See. Don't blindly say the answer. Again, I'm telling you these things. If you blindly say, you guys won't learn anything. Try to think on the knowledge whatever you have and just tell me the answer. That's it. 4, 5, 6, 7.
നീ വെച്ചിട്ടേ ഉക്കാന്നു.
Okay. I think I'm going for 5 options then. Okay, 3. Come on, guys. Come on. Any other options? 4 options are left. You guys are lucky. I gave you 5 options.
Sir, theta at the point B2, at the point C2, and at the point D3, sir. Theta.
Who said 3? Can you guys just respond? How it is 3? Yeah, how it is 3? First of all, I am just curious because at B, horizontal develop, rotation may develop. At C, horizontal develop and rotation may develop. My point is, how come you got up with 3? I just want to
see. D will be at a contact post grid, sir. That means separate points, sir. D will be up. So
no, we are talking about kinematic indeterminacy, right? They will increase more than 4. But how come it is less than 4? We are talking about kinematic indeterminacy, isn't it? So, did you guys confuse with static indeterminacy that you have neglected something? Yeah, am I right? That's why you said 3, or is there any other reason? Can anybody give me confidently what is the answer here? Out of these 5? 6 or 5? What is the correct answer?
I think 6.
Okay.
I think
Sir, at the point D, we don't have moment also.
Yeah, we don't have any.
It is okay. Then it is 6, sir.
6 is
then is it 6? If it is no moment, then it is 6.
Imagine that at point D, just a cable is connected there. Okay. Cable does not resist any movement, isn't it? What it will do, it will resist some part of the displacement along the direction of the cable. That's it. So here there is a possibility of horizontal displacement, there is a possibility of vertical displacement, and also there is a possibility of rotation also. So total number of displacements will be 6. Clear? Any doubt? Any doubt in this case? Why it is 6?
So please explain point.
Imagine, I am telling you again, if it is a free end, you guys don't have any confusion, right? Horizontal will develop, rotation will develop, moment will develop. Is it right? As of now, what we are doing?
Yes.
What we are doing? We are just resisting force acting here. That's it. What it will do? It will resist some of the. Let us say if this is point D. Imagine if the member is going somewhere deflection around like this. Here I'm enhancing so that you guys can understand. So there is a vertical deflection, there is a horizontal deflection, and also there will be some inclined deflection if you want to represent it along the direction of the cable. Here I am not saying that my cable is rigid. If I say my cable is rigid, then this point D will not move anywhere. What this cable will do is that it will resist some part of the displacement, but not all. So at point D, as it would resist only some part of the displacement,
famously said,
because of that, this point can move along the horizontal direction and
because
it can move along the vertical direction. At point D, if I resolve it along two perpendicular directions, how they will look like? This is the perpendicular direction along y direction. This is the force of the cable along x direction, isn't it? Now tell me, is it a support? Can I treat it as a hinge support? No. What is the difference between them? Let us say if I am talking about a cable, let us say horizontal cable, and if I say that some force is acting on there, then what will happen? Because of that force, the elongation will occur, isn't it?
Yes, sir.
Similarly, what is the point of adding the cable here? If there is an excessive deflection at point D, this cable will resist some of the amount. If I say this is completely rigid, that means elongations will not happen in the cable. If elongations won't happen, then what it happens? Indirectly, this we have to treat it like a external support. But in this case, it is not a rigid. This cable can also displace. So what we'll do, even though forces are generating, if I resolve in two perpendicular directions, even though forces are generating along x direction and y direction, these will not completely oppose the displacements. That means there will be deflection that exists at point D. That means if I represent two different cases, suppose if I represent, if there is no cable, imagine that at point D, delta x is 10 mm and delta y is 20 mm. Because of the cable, the deflections might reduce. Let us say it may reduce to 5 mm. Along y direction, it may reduce to 10 mm. But it won't completely zero. They will just reduce the displacements only. So that's why along the D, horizontal displacement is possible, vertical displacement is also possible. In addition to it, there is no internal resistance developing there. So that's why rotation is also possible. So that's why at D we have to consider 3. Is it okay now?
Yes, sir.
Yes, sir.
Okay, just we have to think about the behavior of the cable. If I consider these are axially rigid, can you tell me what might be the answer? If it is axially rigid, then you know right what is meant by axially rigid?
3, sir. 3. Only 3. Rotation at B, rotation at C, and vertical at D.
The member or the cable is in inclined direction. If it is axially rigid, will it move anywhere? This is fixed. Will it move anywhere?
Yes, sir.
Will it move? No. Then how come you get horizontal and vertical? You can't.
We won't get, sir.
This is very ideal case. Rigid means in reality it won't happen. I just want you to think in that way, and so that you can apply in some other problems. Now tell me, if cable is axially rigid, I just want to hear what is the kinematic indeterminacy. Tell me the answers. I can give you the options 3, 4, 2, 5.
2,
sir.
2 then, sir.
Two, sir.
Only, sir. 2, sir.
Only 2 rotations. I thought
No,
it is
sir, not
axially rigidity.
Yeah.
Okay,
Everybody
sir.
with 2, right?
2,
Yes, sir.
2 then,
Yes, sir.
sir. 2.
But I am
2
not.
only.
That's also.
No, sir. Not 2.
You guys are saying 2. What are they? That is
Theta,
rotation.
Theta, beta, C.
theta
But
C.
What I am telling
D
you,
will not.
at D, there won't be any displacements. But what about rotation? At the same time, this kite rotate like this. Even in this case, the displacement is 0, but there is a rotation.
Sir, then reject body means no rotation and no displacement, right, na, sir?
Listen. At this point will not move anywhere. This we are talking about cable only, right? This point will not move anywhere.
Yes,
But
sir.
what about this beam? This beam can rotate without having displacement at point D. What I can do is that indirectly what I have, in which case I have given you, I have given you this case. Now tell me, what is the kinematic indeterminacy?
Actually, rigid case ka, sir.
Now tell me, what is the indeterminacy in this case? Not for axially rigid. I'm just telling you what is the kinematic indeterminacy for this.
3 rotations, theta B, theta C, and theta D.
Let me come to you that point.
And
later.
how about, okay,
Yeah.
sir.
I just want you to let you know that rotations can happen at point D also, as of now at this
They
stage.
also then, okay.
I am telling you is that even if
There
I
is no
replace
change in
cable,
the member AI to D, sir. Then there is no change in the member AI to D, right?
that we will discuss later on. As of now, I am telling you
Okay.
that rotation is possible at point D. If the
Okay.
cable
Possible,
is
sir. Possible,
rigid.
sir.
Do you guys agree with this now?
Yes,
Agree,
sir.
sir.
Agree? Right.
Yes, sir.
Agree.
The answer is not 3. You know why? Because imagine this point is not moving anywhere. Let us say point B might move somewhere here.
Yeah,
Point
sir.
C might move somewhere here.
Yes, sir.
This point won't move, but this is the point B, B dash, and this is the point C, C dash. Even if I say the cables are axially rigid, 3 rotations, theta B, theta C, theta D, in addition to that, what I can say? I can tell you that there is a delta B and also there is a delta C. Or even I can, or more. Now, what is indeterminacy? Sorry, kinematic indeterminacy in this case. At B, we have rotation theta B. At C, we have rotation theta C. At D, we have rotation theta D. At point B, right? Now I might draw the deflected shape. Just see it clearly. Here in this case, what I will do. Now, what is happening? This is what your final position of point B. Now, tell me, at B, how many degrees of freedoms are existing here? Rotation is also possible, and the point B is also moved to some other distance, delta B. Similarly, point C also, rotation is possible. In addition to that, delta C is also possible. So, in addition to 3 rotation plus the horizontal deflection at point B, horizontal deflection at point C. So, total how many? Now got it?
Sir.
Yeah,
Sir,
please.
I have one doubt, sir.
Yeah,
Sir, there is 2 roller support.
yeah.
Single member, 2 roller support. It's acting as a horizontal load, sir. The degree of freedom, how one, sir, previous class.
Sorry, can you please come again?
Sir, 2 roller support, sir. One member. 2 roller support.
2 roller supports are there. You are talking about in between one member.
Yes, sir. Yes, sir.
See, what happens is that, see, if you think about them separately, think about of AB.
Okay, sir.
Now tell me, B can move or not?
Sir?
B can move. Forget about BCCD.
Okay.
At B there is only some roller support is there. Tell me, point B will move or not?
Can move.
Can move, right? Now tell me, if I apply, let me tell you one thing. I think you guys very much clear about bar problems. Imagine here I will apply a force of 10 kilonewton, and at this point I will apply a force of 20 kilonewton. Now tell me, do you really think the displacement at B is equal to the displacement at C?
No, sir. Not possible.
No, sir.
No.
No, sir.
No, then why not here? Here, if it is a beam problem, in addition to that, there are vertical forces also. But if I simply look at about only horizontal forces, is it possible, right? It is possible. Even if I consider this as a fixed, at point B deflection might be different, at point C deflection might be different. Just like the same case here, you can think like this. Deflection at B and deflection at C, they can be different because the member BC, it might compress or it might elongate. We don't know. It's completely upon the type of forces acting in between. Did I justify your doubt? Did you get some clarity at least now, or still?
Yes, sir.
Okay, fine.
No, the previous class one question, sir. One sum, sir. I have small doubt.
No, tell me which one. This one.
Not, sir. Not, sir.
With two roller supports.
Roller
Some
support,
with two roller support.
Here.
No, previous.